Okay, so we have this coding assignment and we have challenge 1 here. It says ask the user how many dogs they want, print out their answer multiplied by 3 combined with a funny message for a hilarious surprise. Okay. All right, so we've opened our editor and it's this REPL.it, right? Okay. And what we're going to do is we're going to create a new file and we're going to call it just exercise1, okay? All right, exercise1.c. It has to be .c, and I always misspell exercise. No, that's correct, exercise, right? Exercise1.c. Okay, so enter. And so now we have this blank exercise.c. Okay, so the first thing I'm going to do is I'm actually going to go ahead and paste in the problem. Okay, so we're not doing a full-blown like writing pseudocode and then doing a flow chart, then writing pseudocode and then translating that pseudocode line for line over into C. Okay, we're kind of just writing it. Okay, which isn't always the best thing to do. A lot of times you want to plan out with pseudocode first. So in this case, what I'm going to do is I'm going to use the question as my pseudocode. Okay, and pseudocode is just a plan for what you're going to program that's in plain English. All right. Okay, so I start off with a comment. Okay, so I have a comment here, /* and then */. Those are the beginning and ends of a comment. And then I'm going to paste in the question. Okay, and hit enter. So ask the user how many dogs they want, print out their answer multiplied by 3 combined with a funny message for a hilarious surprise. Okay, now I know I need a couple of things here, okay? I know I need my include. And I know that I need to make a main function. So I know I need a main function. So in a C program, we always have to have a main function, always. Okay, so C, once it's compiled and run, basically it's looking for a function called main. All right, so we have main. And in C, when we declare a function, we have to declare the return type with the function. All right, and traditionally, main functions in C return an integer 0 if they run correctly. Okay, so we have int main, open close parentheses. These open close parentheses are where we'd pass in values to the function. Even if we have nothing, we still have to have the parentheses. If you want to put in void, that's a best practice there. It won't produce an error if you don't, but just we can put in void just to say there's nothing coming in. Okay. All right, then we also, just to get the skeleton of the function in, we also put our open close curly braces so that we have our code block associated with the function main. Okay, so with the main function, right? Okay, so int main, we're passing in unknown, like a no value, and then we have our code in here. The last thing we're going to do is we're going to put our return value. Okay, we're returning 0. If it runs correctly, it gets all the way to the last line, it returns a 0. Okay, this return of 0 has to match. It has to be the same data type as our return type of the function. Okay, it must match. If we're returning, say if we're returning a character, this would be char, right? If it was a Boolean value like a true or false, this up here it would be bool. All right. Okay, so it has to match the return type. All right, so we have our first thing here. We're going to ask the user how many dogs they want. Okay, now let's start to plan this out a little bit. So we're going to ask the user how many dogs they want. We know that we have to have some place to store their answer, right? So not only do we have to ask the user what they want, we have to get their response, and we have to store their response inside of a variable. Okay, so that's really 3 things. Okay, so we have to declare a variable that we're going to store the response in. We have to tell the user what information they want, and then we have to get their response back and store it inside of a variable. Okay, so those are 3 things. So we're going to declare variable to store user response. Forgive my spelling, response. Okay, next we're going to prompt user to type number of dogs. Okay, then we're going to get user response and store in variable. Okay, so this is like my pseudocode right here, right? Okay, I'm just saying what I need to do on each line, all right, in a comment. And now next to the comment, now I'm going to go ahead and I'm just going to type in, I'm just going to space over a little bit. Remember, C doesn't care about white space. We can put in as much white space as we want. Comments, it doesn't even read comments. That's why we're putting in comments, right? Okay, so declare a variable to store user response. So this, I get my hint, well, what type of variable? A variable has to have a type, so I have to think, well, what type of variable do I want? Is it a name? Like, is it a string of characters, right? That would be a character array. Is it a true or false value? That would be a Boolean, right? In this case, how many? It's clearly a number, right? And also, it's not just a number, right? Because guess what? Nobody wants 1.2 dogs, okay? No one wants 2.3 dogs. They want 3 dogs. They want 2 dogs or 1 dog. They don't want 2.3 dogs, okay? So it's going to be an integer, right? It's going to be a whole number. So int, I'm just going to call it dogs. We could call it anything. Doggos. Okay, dags even. Okay, we could call it dogs, right? So int dogs, that's going to be the number of dogs that I'm storing. I can name it anything. And we're going to think of that dogs as a box, okay? A box with the labeled dogs on it. And the only thing that will fit into that box is an integer. The only thing I can put in the box is an integer. The box has the name dogs on it, okay? When I want to get whatever's stored inside the box, I just use the label on the box, and that label for this box is dogs, okay? All right, so I've declared the variable dogs. It's of int type. Now I'm going to prompt the user to give me a response, right? So we can use puts or printf. There are other things we can use. C has lots of these types of things. The simple ones that we've learned so far are printf and scanf. I'm just going to keep using printf all the time, okay? So it's a little easier for me. Actually, I'm sorry, we're just going to use puts just to begin with, just for simplicity's sake. Puts is a function, right? And it's a function that takes one argument. So we're calling the function puts. The parentheses hold the arguments. Arguments are data we're sending into the function, okay? Inside this puts takes a string as an argument. Okay, so we're going to tell the user, how many dogs do you want? Okay, that's our prompt. So we're prompting the user, okay? Let's go ahead. A good practice to use when programming is just to run it a lot, okay? So basically, you get kind of like this, you get a good go at it, right? Like we wrote a bunch of stuff, right? We got the function declared. We got something going. We're supposed to print out a value. At this point, this is a great time to just go ahead and compile it, see if we get some errors, and then run it, okay? It's really much, much better to incrementally go at these things. So you get kind of something you think will work, right? You get some minimal product, some minimum, program, and then run it. Don't wait till the end to run it. All right. So here we go. So we're going to go ahead and compile it. We'll compile it as shown in the book. We're not going to use this run button up here. Okay. So we're going to type in GCC, that's our compiler, space, whatever the name of the file is. In this case, exercise1. Watch out for misspelling because I'm a terrible speller. So I have to always remember that, hey, I might not have spelled it exactly the same way as it should be spelled. Okay, GCC, that's the name of the program. So I'm saying, hey, GCC, compile exercise1.c, okay? And send the output, that's -o. I'm saying, hey, send the output, lowercase o, to the file with the same name. I could name it anything. In this case, exercise1, okay? Traditionally, we just do exercise1, whatever the name of the file name is, the source file name, but with no .c on the end. And I hit enter. Go. Okay, I always forget my semicolons. Okay, so you notice I got an error, so now I'm just going to up arrow to get my most recent thing that I typed. It's a history. I can just keep up arrowing and just get all of my previous things so I don't have to retype it. So up arrow so I don't have to retype it, enter. Okay. So now it actually compiled, and notice that exercise1 popped up here in my file list. Okay, now this interface is kind of funky, okay? So if I want to see the files that are actually right here, I can just go ls for list, and I can see all the files that are in my current folder, all right? So this terminal down here, we're actually on a Linux virtual machine. Okay, so this is an Ubuntu virtual machine. It has everything Linux, everything. It's just like running a regular computer. All right. Okay. So we have now exercise 1 that we've compiled, right? GCC exercise1.c, output exercise 1, and now we're going to run it. And how we do that is really, really odd in that you don't just type run, which would be too obvious. Okay, we type period / and then the name of the executable file that we want to run. In this case, exercise 1. All right, so that's the name of this right here, right? So we compiled exercise.c, the source file. We got the executable. Now we're going to run the executable. So enter. How many dogs do you want? Yay, it ran. Okay, so it compiled without errors, and then it ran. It gave me the expected output. Okay, so I have a working program at this point. It's a thing to start with, right? So now I know the things I've written are good. Now I can kind of add line by line and just go line by line and make sure each line that I write will run correctly. I just keep running it again and again. It's that easy, right? Okay, get user response and store it. So now what I'm going to do is I'm going to go ahead and get the user response. So we're going to use scanf for that. Scanf parentheses. Always when we're calling something, it's always the name of the function and then open close parentheses. All right. Scanf takes 2 arguments. Puts takes 1 argument. That's the 1 argument in puts. Scanf takes 2 arguments. The first argument is a type. It's in double quotes, and in this case, it's %i. Okay. All right, and then the second argument is the variable that we want to store into. Okay, and I know we're going to get an error here, but I'm just going to go ahead and do it. All right, so let's go ahead and we're going to try to compile this. So we are going to get the user input. It's an integer. We're telling, hey, scanf, we're going to send you an integer here, and we say, and when you get that integer, store it in the variable named dogs. That's what we're saying, right? Okay, so let's go ahead and hit up arrow, up arrow, up arrow. And now we get to our compiler line that we already typed. We don't want to type it again, right? Hit enter. We recompile. Up. It gave me an error. Okay, so let's take a look at it. All right. So we look at now the compiler, this is meant to be helpful. It could just say, hey, it didn't compile. That would be totally unhelpful, right? I mean, you have to have a reason. We want to know, hey, why didn't it compile? We're trying to fix it. So the compiler really is trying to communicate with us, hey, like this is the thing you have to fix in order for me to compile your stuff, right? Okay, so format %i, okay, expects argument of type int, and then this means a pointer, okay? So this star, we are not going to get into pointers right now. A pointer literally means it's pointing at a variable, like the address of a variable, okay? Address in the memory, okay? So basically what it's expecting is an address. We'll get into pointers later, maybe, okay, if it's in the scope of what we're doing. For our purposes, though, guys, if you get that error, if it's saying it's expecting, so format I expects argument of type int, and then star. If you see this star, it's a pointer, okay? And that means we're going to send it an address. And how we do that is we're going to put an ampersand before dogs, okay? If we did a character here, it would tell us the same thing. String, a character array, oddly enough, it doesn't need a pointer, okay? All right, so we're going to go ahead and run it again. So up arrow, compile again. And these seriously, these semicolons are difficult for me. Okay, we compile it. It compiles just fine with no errors. We're going to go ahead and run it. How many dogs do you want? I want 3, enter, and it exits. Great, we're on a roll. Okay. All right, so now I'm down to the next thing. So I've asked the user how many dogs they want, and I've gotten their response, right? Now we're going to print out their response. Okay, so now I'm going to go ahead. Notice that a lot of my program is comments, all right? Comments are like hugging my code, like they're all over the place, right? It's lousy with comments, okay? And that's really what it should be. Now, some things, hey, comments, this one, declare a variable. Maybe you don't need that, okay? But if you have anything more complicated, you really should put in comments. You're going to thank yourself later for the comments. Question? Yes. Great question. It's basically, you have to accept that you're going to forget. So it is not necessary. The only thing that is necessary here is that the compiles your code and that it functions to specification. That means you have correct code. Beyond that, it's a matter of efficiency and style, right? So if it compiles correctly and does what it's supposed to, it's correct. All right. This is a practical exercise in practicality, right? There is no everyone can have their opinion on what's correct. As long as it compiles and functions correctly, it's correct, right? So it's a matter of, so there are things to consider. So one thing is that even if you're the only person that's ever going to see this code, you will forget what you were thinking, okay? Especially if you have a bunch of if statements, nested if statements, like a lot of logic, or code that is like, for example, this scanf right here. If I know for a fact I'm going to forget that this takes a pointer 6 months from now, if I'm programming in a bunch of different languages, I'm using a bunch of different commands, I had to research this to find out how to make it work, right? I might put a note in here to myself saying, hey, you have to use a pointer here, don't mess this up. There's a reason why this looks funky, right? So you kind of have to think, well, what information am I going to need 6 months in the future, right? If you're writing, that's for regular programming. If you're writing something for other people's consumption, there's a whole set of things like, you guys, we're not turning on IntelliSense right now. That means code completion. This actually has code completion. So if you look code intelligence, we can say enabled. Okay, please don't do this. But basically, see how basically now we get like suggestions, right? So as we go, do you see how scanf right here has like a whole set of documentation? Okay, see how we have read more, right? So basically this documentation that's in here is actually written as comments in the programming that defines scanf. So if you're writing like a library that other people are going to use, the comments are actually documentation as you go. So you'd have some documentation that are comments, you'd have some stuff in there for maintenance that are comments. So it's the human readable part of the code. So the code is for the compiler and for functionality. The comments are for the humans working on the code. That's basically what it is. Okay. That was way more than you needed, wasn't it? Yeah, sorry. Yeah. So comments are a deep issue because it's a waste of time, right? Okay, so I would say, let's say you're not a programmer. Let's say you're a manager of programmers. If you look at your code that the people you're hiring are making and you don't see comments, they are shining you on, okay? You are not getting your dollar out of those programmers. So if you look at code and somebody turns in code in a project that you're paying them for and you don't see comments, you should be very suspicious of those programmers, like immediately, right? So because they just don't care, they're making stuff run for 5 minutes and they're not caring whether your business is going to be having maintainable, runnable code in the future once they're gone, right? So comments are a good thing. That's basically it. All right. Okay. So here we are. Print out their answer multiplied by 3. So now in the book we have an example where basically, remember we have this textbook. It's from it's from a federal program. It's available to all K-12 students. So that's why we have our backup copy here. It's through O'Reilly. Okay. So if we take a look at the code we have here, that's kind of our sample that we were kind of working off of, notice that they do dex times 52 here, okay? So we can just multiply dogs right in the printf function, but that would be very confusing. And honestly, it's not good practice, okay? So we want to go ahead and multiply number of dogs by 3. That's one thing. And then we want to print out funny response. Okay? Containing dogs times 3. Okay. All right, so there's our next 2 lines. So first we're going to multiply dogs times 3. Remember, we can reference itself, so we can say number equals number times 3, and now number is going to be 3 times what it used to be, right? So we're going to do that with dogs. So dogs equals dogs times 3. Okay, so now dogs has been multiplied. Okay, remember the star is the thing for multiplication. And then we're going to go ahead and do printf. So printf is just like puts, okay, except it takes at least 2 variables. 2 arguments. Okay, so our first one is a string, okay? And we're going to say, wow, we're going to put in whatever they typed, right? So it's going to be an integer. So it's, again, just like scanf, we have to say, hey, it's kind of the opposite. Like scanf is taking input and saving it in a variable. Printf is taking what's already stored in a variable and replacing it inside of a string. So we're going to say, wow, you want so many dogs? Dogs. My hilarious, woof. You want so many dogs? Talk about muttification. That's amazing. All right, so, okay. Sorry, because we're multiplying. So thank you. I just misspelled it earlier, so now yeah, it's a terrible joke. Okay, all right, so we have %i, basically, we have a %i that's going to get replaced by dogs, okay? So that's it. In this case, it doesn't need a pointer, all right? Or sorry, it doesn't need an address. It just needs a regular variable, okay? So let's go ahead and run this and see if it goes. Okay, remember we have to compile each time. Arrow up to run it. How many dogs do I want? I want 4. Woof, you want 12 dogs. Talk about modification. Okay, so, all right, now we have a couple weird things here, right? Okay, so let's just talk just for a second about printf, okay? So one, it didn't give us a new line right here, all right? That's kind of odd, right? So we didn't put a new line character at the end of the line. And so if we had more than one of these, what we would get, let's go ahead and just take a look at it. What if we had 2 in a row like this? It would start to get pretty confusing. So, okay, so notice that there's no line break. It just keeps writing on the same line. So in order to get a new line, we have to put an invisible character. Okay, that's a new line character. I think it's backslash. And this is, we call this a new line. There's also a carriage return, which is from a typewriter, if you know what a typewriter is. The carriage is that thing that moves across the typewriter, and the return was you had to hit a lever to move it back to the, advance the paper and move it back so you could keep typing a new line. That's a carriage return. It's the carriage is the part of the typewriter. Okay, so new line is like another word for that. It's like a different thing other than a carriage return. So \n is the hidden character that causes it to advance one line, right? Okay. The other thing we want to take a look at is what if we have more than this? Like what if we have many, many, many? Like say we want 4 different values. Okay, all we're going to do is we're just going to keep putting commas on as we go. Okay, so this dogs would replace this I. The second dogs would replace the second I. The third dogs would replace the third I, and so on, right? You could have many, many variables getting replaced all at once, just in a row, all right? And that's basically it. Okay, so let's take a look at how this runs. Okay, I want 7. Wow, woof, you want 21, 21, 21 dogs? Talk about modification. Okay, so that is it. All right, so that's basically how I would have approached that problem. I hope it's helpful to you. Thinking through, adding in some comments first, compiling the code early, running it each time you add a little bit of code, I think is very helpful, especially when you first start. Trying to write everything out and run it when it's all written can be very problematic. Okay, best of luck on that.